Hello everybody, welcome to the Henstitute. In this one we're going to kind of look at this Robin Hood Atwood machine. So we've got Robin Hood over here and we have a chandelier. So this is kind of that classic picture that you see in some old-time movies where he's going to cut the rope, and basically what's going to happen is there's going to be a force up on him. That's going to be the force of tension. And it's passing over here. We don't actually have any pulleys, but the idea is this up here is massless or is frictionless. So we're going to pass over these beams and the chandelier is going to fall. It's going to land on these people trying to get him and he's going to get away. So the idea is he's going to jump through that open door up here. So we'll escape. The other force that's going to be acting on Robin Hood is obviously his weight is going to be pulling down, or the force of gravity. And then over here we have another force of gravity. I'm going to change the green just slightly. So we have the force of gravity of the chandelier. And it also is going to have a tension force acting on it. And these tension forces should be the same. So because we're dealing with an Atwood's machine here. And I came up with a way of relating all this before, but we can figure out what his acceleration is going to be and what the acceleration of the chandelier, they should be the same. So I need to kind of designate them as mass 1 and mass 2. So just for simplicity's sake, I'll make Robin Hood be mass 1 over here, and I'm going to make the chandelier be mass 2. So the idea is when I set this up, we had a way of actually finding the acceleration. We did this for our Atwood's machine lab. It's equal to gravity times, we have the difference in their masses, so it's going to be mass number 2 minus mass number 1. So in essence, basically, it's the difference between the force of gravity on these two objects that's causing a net force on these objects, but it's accelerating the total mass. So this is how we're going to find the acceleration of Robin Hood upward and the acceleration of the chandelier downward. And when we plug this in, we're going to get just a positive value, and that's going to find his acceleration. It already says that we want it in the upward direction, and we've got it. Tension was a little bit more difficult, but not too bad, and we had a way of finding that tension. Let's see if I can do a different equation here. So the force of tension, basically what we've got is over here on Robin Hood, you have the tension and the force of gravity kind of creating something, and then over here with our chandelier we have a tension, and we had a way of actually calculating that tension. Basically from our Atwood's machine and tension video notes, we came up with this, that it was equal to 2 times mass 2, so that'd be the mass of the chandelier, times gravity, so really just twice the weight of the chandelier over 1 plus the ratio of their masses, so mass 2 over mass 1. And these are a couple of things that we're going to make sure that we throw onto an equation sheet, or that you have this written down somewhere. These are specific equations for an Atwood's machine, so we want to make sure that we have that kind of idea. Once you have those two lovely equations, you just plug in all the information you know. You know the mass of Robin Hood, you know the mass of the chandelier, and you know the acceleration of gravity, which is 9.8, and you've got everything solved. Hope this helps on the Robin Hood problem, which is problem number 9.